It has a maximum operating temperature of about 104 degrees. So there are times in the summer where the drone is too hot and it overheats, and we have to wait for it to cool down. And it's quite sad, actually. This one has a single GPS GLONASS kind of GPS system. This one has an RTK injected into it, so it's GNSS enabled. Oh no, geez. Okay, so this is our big drone, the one back here. It's called the Harris Aerial H6HE Plus Electric Hexacopter. So it is fully Department of Defense approved. It's on the list. It's completely customizable. So we can get new sensors, we can get new batteries, we can put a generator on it. Like we can continue to upgrade it and customize it fully for ourselves and other projects. So it has about a 45-minute flight time in this electric version, and it has about a 5-mile range with ideal visual conditions. It weighs about 180 kilograms or 400 pounds for all of its constituents. So it is very much limited to being within distance to a car or something. I'm not bringing it to a wetland. It has about an 8-foot wingspan. So from this tip to this tip over here is about 8 feet. And it has a maximum operating temperature of about 120 degrees Fahrenheit. We have 3 sensors on it at the moment. So we have a LiDAR sensor, which is this little thing right here. We have a multi-spectral sensor right here, and we have a thermal sensor on the drone itself right now. So these sensors are all DoD approved. We have the TrueView 515B LiDAR sensor. I'll talk more about that later. We also have the MicroSense Ultim PT multispectral sensor. Sneha will talk more about that in a bit, and she'll also talk more about the Orbital Wireless Enterprise Thermal Sensor. So every drone project kind of has 3 different stages. So stage number 1 is the acquisition stage. So in this, we have like pre-flight planning. So that means like obtaining all the permits and notifying appropriate parties. We need to create the mission polygon and decide on ground control point locations and kind of make sure the drone is okay to fly for that day. During the actual flight, you again make sure your drone is okay to take off. Everything is turned on, plugged in, all the things. And then we fly the entire site for both LiDAR and multispectral at the same time, kind of co-mounted together. This results in a ridiculous amount of data. At Steigerwald alone, we have almost 4 terabytes of data. We collected about 12 terabytes of data over the summer, and so far we have about 8 terabytes of processed stuff. After we finish doing the LiDAR and multispectral, we fly targeted locations with the thermal sensor. And we do this all in a software called Mission Planner. Then next step is processing everything. So number 1, we process the LiDAR. We do that in LP360, and ultimately we create a classified point cloud. With that classified point cloud, we create DEMs, canopy models, and we can like count trees and do channel cross sections. And it's a super dense point cloud. We can do a lot of stuff with it. Next, we have the multispectral sensor. So we process this in Pix4D and composite everything in ArcPro. So that makes orthomosaics, indices, reflectance maps, and we can do like thermal mapping with it, veg indices, that kind of thing. Our thermal sensor, we use ThermoLab to process that, and we can do like explicit thermal investigations. So we create like map how like Gibbons channel empties into Steigerwald and the thermal effect of that. Lastly, we have to report everything. So here's a short list of things we report on and can report on. And this will be a large part of the discussion later on. So step 1, the acquisition of drone data. So number 1, I'm going to talk about ground control points because these are pretty critical. So this one on the left is about 12 inches across. This one on the right is about 4 feet across. So these are 2 different maps. This is Steigerwald, and this is for the ski youngs. We generally put about 5 ground control points per site, or around 1 every 30 acres. A DJI drone requires about 1 every 10 acres. Safety is our number 1 concern for putting these out. This part of Woliski is a death trap. We don't go there. So that's why there's no ground control points down here. But Steigerwald, it's pretty safe to go everywhere, so it has a much better coverage of ground control points. So drone flights, how do they actually like work? How do we get data out of it? And this might be a bit basic for some people. Apologies, but I felt it was important to include. So number one, we get ready to go take off. So we launch and go over there. And we do a single pass. This pass is about 20 meters wide, or 12.7. Sorry. We get ready for the next pass, and then we go back down the other way. And then you do it again. So we do that about 112 times for this site. This took about 2.5 hours to do. And then we stitch all of this together and make fun products out of it. So I'm going to talk about the LiDAR sensor now. So as mentioned previously, we have the TrueView 515B LiDAR sensor. So it contains two different RGB cameras. One is here and the other is here. They're at an angle. So it captures the entire, I guess, 40-degree swath that this laser scanner captures. We have an infrared scanner, so it has pretty decent vegetation penetration. It can go through about 15 or 16 layers of vegetation. It's very precise, pretty accurate, and yeah, I'll talk more about the accuracy and precision in a little bit as well. So how does LiDAR actually function? So we fly back and forth, as I mentioned earlier. All right, so at each of these points, it shoots off lasers pretty rapidly. So the very first return is always the canopy top. Occasionally we'll get like a raindrop or something, but that just is classified as noise. So the second return, just canopy. Third return, canopy. Fourth return, more canopy. And then the last return is ground. So yeah, that's basic. So we can penetrate some vegetation. We cannot, so as you continue on, we get to the water. The only return we get is the water. We'll get like 10 returns or so from that water surface, but we don't see anything below the water with our infrared LiDAR. If the vegetation is too thick, we cannot see the ground. So that means a super dense blackberry bramble, we can't see the ground. We occasionally will see spots on the ground, so we can kind of tin everything and make still a pretty accurate digital elevation model, but we can't see it directly often. So some pretty pictures finally. Right, so this is classified LiDAR. So this is kind of after you process everything, and this is what it looks like. So this is visible light. So this is real color of a single spot along Willisky. This black is where there's water, and we've cleaned those points out. This middle one is classified by elevation. So you can really see just how the channel kind of grows and like ebbs and flows and stuff. This bottom one is the classified one. So this dark green is low vegetation, the orange is ground, and the light green is high vegetation. So in here, it's hard to see, but there is a bunch of like about 2-inch tall little plants in here. So we can see that all with the LiDAR. So I would be remiss if I don't discuss the accuracy and the precision. So the LiDAR we're producing has about a 3-centimeter precision across the wetland and about a 5-centimeter vertical accuracy compared to a Top Gun RTKs. And we have about 1,500 points per square meter, or a ground sampling distance of 2 centimeters. And we've explicitly designed our surveys for the wetland. Comparing that with like standard QL1 LiDAR from the USGS, they have about a 6-centimeter precision and 10-centimeter accuracy. And they only really care about like hard surfaces like this road right here. So we use that for a lot of our comparisons to see how exactly accurate we are at these sites. So time for some fun results. So one of the big things we can do is track channel development with our just straight elevations. So this is Willisky Young's. This is a 2010 LiDAR map. So in here you can see some channels and then the kind of connected site over here. Over here, this blue is all the channels that they dug during kind of restoration. And these oranges are mounds that they made. So this is the south side. You can really see some channels beginning to develop through here. And I mean, it's just a fun picture. So yeah, here's the north, same thing. You can see a lot of channels beginning to develop up here. We're going to focus on this little section right down here in a moment. Channel cross sections. Again, everything must be dry. We can't see through the water. So at low tide, this is pretty majestic. We're moving about 1 meter per frame upstream, and you can just watch everything get, like, the channel start to narrow up, get steeper, that kind of thing. I'll let the GIF play through again. This really augments manually collected cross sections. So this is a beaver dam, what it looks like in that same kind of cross section. So this is downstream. We're going along the top of the water. It's kind of rough because it was slightly windy when we flew this part. We have the beaver dam right in the middle. It rises up, and then we have an upstream water surface. Here's another beaver dam. This is at Steigerwald. It's right here. I don't have a better picture, sorry, but it's like this massive thing that you can really see. This is what it looks like in the LiDAR. So this blue is water surface. This kind of colorful thing is the beaver dam. Trees are the nemesis of everybody doing LiDAR, I think. So areas with super thick canopies, we can still get some LiDAR out of it. It does reduce the quality of the LiDAR from under Keywall 0 to about Keywall 1. Leaf off conditions do create like a super great LiDAR surface though. And we can just, do tree counts, carbon stock, speciation, etc. So this is what it actually ends up looking like. So this is the tree and just the point cloud. This is the surface. So you can really see these like smoother triangles. This is where we have less ground coverage. This kind of stuff over here, we just saw everything. This is what it looks like when we're trying to kind of count the trees, if you will. So every single one of these slope changes is a tree crown. Here's a better example of that. This is at Steigerwald counting kind of the planting effectiveness and the planting survival rates. So you can see we might need to do some infill planting right through here. And if we wanted to, we could count the density, count them entirely, do survival ratios, growth rates, etc. Additionally, we can do as-built specs. So I think this is particularly useful for some people. This is one of the levees at Steigerwald overlaid underneath the LiDAR. So you can see it basically lines up exactly, which is pretty cool. And now I'm going to turn it over to Sneha to talk about the multi-spectral stuff.
Thanks, Ian. Clearly, Ian's done an amazing job going through every single LiDAR capability that we have. And I'm going to turn the wheel a little bit and talk about the multispectral and the thermal capabilities that we were able to bring on when we purchased the Blue UAS approved drone. So Ian, will you be able to advance the slides for me? Thank you. All right. So when we purchased our new drone, we also upgraded our multispectral sensor to the MicaSense Ultim PT. Now, a multispectral sensor is good at picking up non-visible light that's emitted by objects at our sites. And the MicaSense that we purchased is a 5-band sensor. In addition to that, it also has a high-resolution panchromatic imager as well as a thermal camera. When we compare this to the DJI drones that we've had, it's different in terms of like this camera right here has higher resolutions in terms of its individual spectral sensors. On the DJI camera, we had a multispectral, like each spectral band was collected at 2 MPs, whereas this one, each spectral band is collected at 3.2. We also have a panchromatic imager, and for folks on the call who don't know what that is, basically it's an additional sensor that collects secondary RGB information and feeds that information into these individual spectral bands, which then improves on the resolution of our final products. And of course, we have the long wave IR sensor as well, which allows us to pick up the thermal energy being reflected off by these plants. This is fully RTK enabled, and we collect this using Mission Planner like Ian spoke about. I'm not going to go over that anymore. One of the biggest differences is the amount of high resolution data that we get when we compare this to the DJI drone. We get like at least 3 or 4 times more data than previously that we've collected. Now, how does this look in the field, right? So first, let me talk a little bit about the DJI fieldwork. Back in 2020, 2021, we used to have like a huge field crew, and we would, split off, set up vegetation grids, and Narayan mainly would run around Voluski and set up ground control points. Using DJI drones, it was necessary for us to set up 31 ground control points to be able to get a very good DTM and RGB orthomosaic. Following the normal UAV flying protocols like flown at 300 feet, 80% forelap and side lap, it took us about 2 days to cover the entire site. When we compare this to the Harris aerial drone, we flew the drone last fall, and it was just us. We took about a little bit of time GCPing about 15 locations. We also collected plant information, photo points, etc. Following the same protocols of 300 feet flight and 80% forelap and side lap, we were able to complete the flight in about 2.5 to 3 hours. So there's a huge difference in like the labor cost that goes into flying basically on the UAV side of the work that we do right now. In addition to that, the Pix4D products that we get are also very we have a lot of high resolution in these products. In addition to using these individual spectral bands to go to create RGB composites or an orthomosaic reflectance maps, we also have the ability of creating a thermal infrared map. And these information goes beyond answering questions about vegetation communities, right? We have individual spectral bands, which can also be used to answer questions about riparian buffer effectiveness. We also have the capability of pulling out turbidity as well as chlorophyll A absorption using these individual spectral bands. Moreover, because we have all of this new information, high resolution information available, we were also able to create additional vegetation indices, which we then feed into our vegetation modeling. Now, I've just shown some examples on the screen. The NDVI is something that's very common. It calculates the amount of green vegetation that's on the site, and we use that for classifying different spectral signature of the vegetation species. However, you need to capture this at like peak vegetation to be able to actually talk about which species is where. However, with our drone, we are now capable of producing NDRE, which is normalized difference red edge, as well as EVI, which capture signatures from plants that are not at this peak biomass or peak growth rates. So it also extends our drone flight period to maybe say late spring, mid to late spring, all the way to like fall. What is the use of this, right? Like, so we can also assess like vegetation health at our restoration sites. We can also predict invasive species, and overall, we can evaluate the impact of several restoration efforts at these sites. At LSET, now we're also trying to combine all of this with machine learning and AI. We started doing this like a couple of years ago, but with these new products, it's become vastly easier for us to like pull out information. One of the biggest ways we use this information is to not only track plant communities, but also be able to predictively model what a restoration site or what a newly constructed restoration site could look like, say, 3 years post-restoration, 5-year post-restoration, or even if we have enough reconstruction data available, hopefully even like 10-year post-restoration, how a site could look. We also, because of the LiDAR capabilities we have now, we can use the tree canopy cover to calculate how much carbon stock is present at a site. We are also currently using these vegetation models and sediment models that we are creating with, well, we hope to collaborate that with the data that Joe and Jen are collecting as part of our carbon study at the site to be able to model what these carbon rates or greenhouse gas emission rates look like across the site. Now, I spoke so much about vegetation communities and how these restoration, how it can affect or enhance restoration and monitoring at our sites. But we also have to think about climate change. We have to think about how these, how rising temperatures could be mitigated, and our thermal sensor comes into play with that. We have now a Workswell enterprise camera, which has a pretty high resolution of pixels. It has a spectral range of 7.5 to 13.5 and is integrated with a laser finder to measure accurately like how far away it is, how far are the features away from the camera. The uses of this is we can basically detect like hot pockets around the site for assessing water temperature patterns. We can also, with more and more data that we collect, we can also identify areas at the site that have, sedimentation or erosion issues. And over time, we can also assess vegetation health and the growth of riparian buffers. I just want to show what this looks like. This is a photo of Walluski Youngs, and if you all can see, there are some warmer spots that correlate to, like, for example, there's like a little bit of a warm spot near where the levee was supposed to be, and then further in, when you go into the site, there are some water pools that have slightly elevated temperatures, but like you can actually see that with the normal RGB camera. So this is another very powerful tool for us, and we're very excited to figure out what this means and how we can use this for future restoration projects. Another thing that I want to show you is something we saw in Franz Lake. We had a flight in early February, and we wanted to. The restoration practitioners are interested in seeing the current connectivity to Columbia River, and all the way in the left is the Columbia River, where we can see like the temperature of 4 degrees Celsius, and inside the Franz Lake itself is a lot warmer, which kind of answers how much connectivity is, like how connected it is, and what actions we need to take to improve its connectivity. Now, I've already tried to go over this while I explained the sensors, but in a nutshell, I'd like to reiterate how our products can enhance reporting and research and restoration. When our models are combined with the hydrology, we can also predict the shifts in habitat conditions. This can also help with sea level rise scenarios. And overall, we hope that these products can assist in restoration planning, in project design, and with adaptive management, which is so important in so many of our sites right now. I also want to point out that with our drone capabilities, we've been able to shift essentially wetland plant community data collection from a little bit, or like maybe like 0.2%, 0.2 acres of the site to essentially as big as your site is. And this is really powerful, right? Like being able to see where the vegetation is at and predict where it goes is also a very important tool. And then, of course, beyond these, we have the capability to track channel developments, variation in topography, also take carbon into account, and thermal sensing and everything. With this, our next steps, right? So the thermal sensing thermal and LiDAR are very new to us. So we're currently working on refining our methodology for thermal sensing on the ground. Basically, what data we need to be collecting to be able to cross-check and QA/QC our thermal imagery. We're also going to utilize our LiDAR to evaluate the sediment dynamic and the topographic changes of our restoration sites. We also want to develop predictive models for the vegetation developments vegetation at our restoration sites using machine learning. And the new individual spectral bands that we have, we want to use that to study the plant health and biomass that's available at each of these restoration sites. Moving forward and looking into the future, we also want to leverage all of this new higher resolution data we have to be able to work with partners and maybe align these products better with the restoration goals that our partners have, and looking way ahead into the future. We've already started trying this, but we also want to integrate more AI. If it takes right now, Ian and me, about 2 weeks to hone in the model to the extent that we think is accurate, that our data shows that it's accurate. But if we could have AI as the third member that could finish everything in a day, that would be awesome. Yeah, so we're very excited to follow this journey. And I would also like to thank our partners, mainly Crest, for coming out with us all these years and running around the site with us, applying all these GCPs and everything. Columbia Land Trust for allowing us to access their sites and be willing to work with us in the future restoration sites as well. And of course, BPA, OHSU, Cowlitz Indian Tribe for letting us use Voluski in so many of our different projects. Yeah, thank you very much, everyone.
Great, thanks. I'm sure so many people have a lot of questions. Yeah. Would it make sense to hold the questions, because I'm sure there's a ton? Could we have Curtis present, and then we're going to get into a round robin of the use of drones by partners, and then there's a conversation about the capabilities of the drone and how we're going to work together on it. So does it make sense to hold the questions until after Curtis in the round robin? Does that sound okay with everybody? Okay, because I'm sure there's going to be time. Curtis, are you ready? Or
I think I'm ready to go, and I don't have that many slides, so we can I'll go through these pretty quick and we can move right along. Let me see if I can get this set up, so I hope it'll work. Yes, share that, start that. Everybody see that?
Yep.
Okay. First of all, that was fantastic by Sneda and Ian. Wow, what a I am quite jealous of all the incredible equipment you guys have. Way better than what we had to work with. So I'm going to go into more of a conceptual talk here and try to move forward past the actual flights and everything into what do we do with the data and what should we get out of it. And this is based on some work that I did with Amy Bordy and Andre Coleman. We worked in both wetlands and also some intertidal stuff in Willapa Bay. And with various sensors, LiDARs, and hyperspectral cameras, and ground truthing was super important. And Andre and Amy really worked on the machine learning aspect, which I thought was amazing in its capabilities. As Sneda mentioned, this is kind of the way of the future for sure. But the output for these is high resolution spatial maps, very high resolution with so much data. And here's some examples of what we can do with it, because the point is taking this data and what do we want to get out of it? For a lot of things, it's actually measuring change over time. So here are a couple examples from our sites. This is Steamboat taking using a hyperspectral imagery 3 years apart, and we can identify these different plant communities here and then categorize them and show differences over time. So this is, to me, is like the main point for measuring trajectories of restorations. We want to be able to do it over time, high resolution, but then collapse the data down into something that we can actually use. Here's
Hey, Curtis,
yes.
can you put it in presentation mode? Sorry, folks can't see your slides. Is that what you're going to say, Sam?
The same thing.
Okay.
Presentation mode. Can you see that?
If you go up to slideshow up at the top.
Yeah. Okay.
Up at the top,
Sorry,
slideshow. That's all
slideshow.
good. There you go. Yeah, and then from beginning. There you go. Should work.
I thought I did that. All right. So is that showing? Do you guys see this?
It's no. It's still the same thing. Huh.
Okay, hold on. This sometimes. How about here? You see that?
Yeah, but you still see the slides off to the side, and it's kind of smaller. You hit the from beginning. Are you saying? Yeah.
It's from beginning.
Oh, okay.
Can you see that? Can you see that change?
Yeah. Is it right, y'all?
You might be showing the wrong window.
Yeah.
There's only one window open.
It's probably not worth it, y'all.
If you hit the button in the lower right of your screen into presentation mode.
Yeah, that's what I did before. So is that not showing?
Yeah, it's all good, guys. Let's just go. Sorry, Curtis.
I mean, can you see the slides or not?
Yeah, we can. It's just they're a little bit smaller.
Okay.
So,
sorry about that. I'm not sure what's going on, but
okay.
Okay. These are two examples of using sequential measurements of a site to extract change, data about change. So one on the left over here, I don't know if you can see this, but Steamboat, we used the hyperspectral imagery and or RGB and machine learning to categorize all of these communities by species. So this is highly we can tell which species are where, but then we can categorize those into different groups. Or we can use the LiDAR on the site over here. This is a Corps of Engineers sediment deposition site, and you can see the change from 2010 to 2020, how much sediment has changed over that time. So these are just examples of using the drones to measure spatial change. And if we look at all the different metrics, I'm not sure you can see the slide, but there are a whole bunch of things, as Sneda and Ian were showing, that can be extracted from these data sets, including physical things about the channels or the wetlands, species ID, which ones are invasive. All these metrics can be removed. And by linking it with things like hydrology and water instruments, you can get inundation times, where the plant communities are in relation to the different zones, things like that. Or you can actually use circulation models with hydrology if you know the topography. So it's interesting to compare what we can do with drones with what we have been working with for years with our initial restoration protocols. And I would argue that for the biological stuff, the habitats and plants, it's actually probably better with UAS, mainly because it's such a larger spatial scale that you can image. Of course, you don't get everything that you can with a survey, but it's so much quicker, faster, and spatially relevant. And linking with like I was just saying, with the hydrology, you can get all these other parameters that are important for the plant communities and things like that. And the only thing we really need to do from the protocols is still use nets for the fish. So I think that the drones are the way to go, and we can eliminate a lot of time and get an immense amount of spatial data. But what do we do with all that? So I'm just going to say that these systems are pretty much operational now. The sensors and everything on the drones are theirs, as we've seen. Developing the machine learning techniques are going to be super important. And we want to be able to develop metrics then specific to our system that we can extract from this data and use that to concentrate on output assessment and management. So here's just a couple of sort of thought patterns, a few slides on concepts of what we can do. So let's take on
Curtis.
Yes.
Sorry, this is Amy. We can see your slide, but they're not advancing. So we pretty much only see the second slide that you got to. So I don't know if you can manually go to the slide you're at somehow.
Okay, sorry guys, someone told me that earlier, but okay. Can you see that slide? Wow, this is a fail. You can't see these slides at all?
No, I think we're seeing slide 6 at this point. So ground truth data and analytical output indicator metric. Is that what you're? Yeah.
No. Okay.
Okay.
How about this one?
Well, that was. Okay. Which one are you? Yeah.
You may want to.
We're back. Sorry. Go ahead.
You may want to unshare, and then when you from the sharing menu, go down and select the one specifically for PowerPoint. That has worked for me in the past.
Okay, let's try that. Share is here.
So if you go to Windows instead of screen, then it should show just your PowerPoint window.
How about that one? I am sharing. Can't see that?
Looks the same. We can see it. It's on slide 6, but somehow it just isn't advancing when you're advancing.
Well, I'm not sure what to do.
Okay. Yeah, I think we can see the ground truth data, indicator metric, comparative reference, and then the enable time series measurements. That slide with all the graphs.
Okay, good. I'll just use this one then. I'm sorry about this, guys. All right, so this is just a concept piece and example of how to extract some metrics that we might want to use for evaluating change. So here we have some of the data that we can pull out on the left top. It's an exposure gradient with all the species that we can measure with machine learning outputs. And we can categorize those into many different things, like what intertidal zonation they are. So we can do high marsh, low marsh, which ones are invasive, or we can do something like topographic inundation. There's lots of examples. But the idea then is to take your actual sample and then compare it to what's known as like desired future condition, or it could be a baseline, or it could be what are the marshes surrounding it look like? How do you want your end result to be? And so from your desired condition, you then repeatedly measure. So for instance, you do before restoration action, and then you follow that over time to see where your different categories go. But then you might want to pick out some specific indicators, for instance, the percent invasive, by area, or like a certain marsh area, like the high marsh, and you track that over time, and you see where it comes into your target threshold levels. So by monitoring that over time, you can see if there's a change in your projected trajectory towards your desired state. If there is, that's a time where you can intervene on your site and do some actions. For instance, if you see that there's invasive species blooming where they shouldn't, you not only know that, but because of the spatial data where it is, and you can infect a change to go out and hopefully eradicate that problem. So I don't know, can you see this slide?
Yes, you can see it.
Okay.
Thanks.
So here's just the last one I'm going to show you, and it's an idea of like that the community has to come together to develop what are the baselines, first of all, what do we expect these marshes to turn into, and then which indicators are best for monitoring those. And remember, this is like an idea to be able to extract a lot of data from these gigantic data sets for a few metrics that can be pulled out easily with machine learning and then plopped into a plot like this to see where these are over time. So one idea is to use like anomalies or slopes. So if you have your baseline data and it's some kind of percent, you want your marsh to be some kind of percent in these areas, you can subtract that from your baseline and within some range and know that if your site is going according to your ideal. And you can add, with anomalies, you can add a bunch of the indicators together from one site onto one plot to see how things are tracking. Or you can use baselines from a region, like a reach, where things are probably pretty similar because of the hydrography, and then see where where individual sites compare to the baseline area. So here you can put all of your different sites with certain metrics into a common format. And again, the idea is to look and see where things are not going towards trajectory, so that there can be a management approach to do something about it, perhaps. And last thing I'll show is that this data can also be used just for regular sites to measure for ecological stability over time. And for instance, if a climatic stressor or something comes in, you can see if some of these metrics that we've picked fall out of the baseline zone you want them to be. And again, that will be indicative of some perhaps something that we can do to help out. So I apologize for this kind of flail on the PowerPoint, but just to sum up, then there's so many advantages to the UAS. I think it's obvious this is the way we're going to go and be sampling in the future. I think the machine learning protocols are a key aspect for crunching down these big data sets. We need some kind of assessment framework and finding metrics that we agree would be triggers for objective management options, we find. And as we've seen just from Ian and Sneda's talk, all these systems are rapidly evolving. There's so much now it's plug and play. So it's really going to be, I think, a great opportunity for us to get on and use these tools in the future. I don't really see these cons or anything really bad at all. There's a few understory species we might not be able to go, but they're part of the community that we're going to be monitoring in a larger sense. So it will reduce time in the field. So for those who love the field, that could be a problem. Okay, again, sorry about that. That's what I have.
Great, thanks. The next thing is a round robin on the use of drones by partners. Do we want to set aside a couple minutes to discuss the first two presentations and then get into a round robin? Does that make sense? I don't know if anybody has any questions for Curtis. If not, how about we discuss what folks are using drones for now? So I know Narayan and Cress, and I think Amy, you both had some ideas of what you all are doing now. Narayan, I'm going to pick on you if you're comfortable.
Bring it on, Catherine.
I know you do. So I know you do a lot of drone work. So do you want to talk about what you do now, or?
Yeah, sure. I think what I do now is archaic compared to what you guys are doing, but for years now we've been using our CREST UAS program to gather RGB only imagery to construct orthomosaics and DTMs for and photo points for different applications. The orthomosaics we use to track changes over time using GIS and map algebra, how sediment moves within our sites from pre to, years post project. We also look at vegetation, and that takes a lot of ground truthing, delineating different vegetation communities and picking that up with the drone imagery and seeing how, after an altered hydrologic regime is introduced into a site, how that community is affected or changed, or, mainly speaking to invasive species like reed canary grass, purple loosestrife, yellow flag iris. We also use it for as-builts, like you guys mentioned, but with our, older technology, it only works in areas that have been recently constructed, where the vegetation is removed and you're down to just dirt, mud. It works really well in those applications to create a DTM, and from that create topo lines. And those topo lines are used as a comparison over time to see how a site is changing. But once you have, 3 feet of reed canary grass, oh, I shouldn't say reed canary grass because that's not what we want. I should say maybe some Deschampsia cespitosa or something like that. Once that colonizes a site and you have 3 feet of vegetation biomass, it doesn't really work. But going forward, along with, and that's really what I like, one of my main questions to you guys, like, great work, post-processing all that data and the products you guys presented on. That was very visually pleasing, and I'm happy to see that all that hard work, those hours and heavy lifting has panned out to those products. But I'm also interested on like how accessible that's going to be to the other SERP sponsors, other partners. I'm sure you'll talk about that. But on top of that, it's not feasible for us to rely on that specific UAS drone for all of our sites. So we are looking right now, and I've been looking for years, but with the regulations, as you guys know, moving and shifting so much, so fast, I've decided, because it's, it's expensive, so I've decided to just wait a little bit. And finally, I think it's at a place where, all right, you just need a blue UAS, a Department of Interior approved drone. That's what we need. So that's what we're looking to get. It won't be as big as yours. We won't have LiDAR right now. It's too expensive, but we will have a multi-spec, a good mapping camera, RTK enabled, PPK enabled. Yeah, so that's coming this year. And yeah, that's how we use it. Orthomosaics, but hopefully soon getting into the multi-spectral, infrared vegetation band technology as well.
Okay. Just to, so like it's kind of, I think, like getting back to like what Curtis was talking about. I mean, like if we come up with as a region some monitoring metrics and indicators and how frequently we fly, is it feasible that this drone would be able to help you like once a year or something like that for like all your sites or something like that? I mean, like we would have to kind of come up with a plan and how that would work, but it might be feasible to do a one-off sort of like a one-time thing for a site and then move on to the next site, to the next site. It's just really like based on like the need for all the different partners and what the time and the resources and that kind of thing. But anyways, it might be something that's doable, but I guess that's a long conversation we can have. Just to augment what you all are planning on doing in the future.
Yeah, agreed. And it's such a production to fly that thing. And I'm sure post-processing is even more of a production. So I don't think it's feasible to do every site, but maybe our big sites, big acreage, where that would make sense, because everything else we could fly ourselves and we could use the LiDAR that's available. But for big sites, like I don't know, like we're already doing West Sand and Polensky, but big acreage sites, that's where I think it makes the most sense. And yeah, maybe
Okay.
1 or 2 a year.
Yeah. Okay, sounds good. Anybody else want to discuss what they're doing?
I can go. This is Amy Bordy.
Great, thanks, Amy.
So we have a 5-band drone that is fairly new to us. We got it last year. And we spent a fair bit of time in the field last summer, going to a bunch of different sites. And we've been working on using different machine learning methods to work primarily on classification. And this is based on some of the work that we did with Curtis and folks at P&L, in which we worked on using random forest machine learning on just 3-band imagery, and we're able to get pretty good classification results from that. So we're looking at using that same methodology. Elizabeth Martin, who's on the call, has been doing the heavy lifting on that. And it's still work in progress. There's lots and lots of ways to tweak those algorithms. And so I have hope, but it's not, we're not done by any means yet. But I think it is a very promising application, and certainly having the multi-spectral, at least 5 bands, I think helps a lot, although it does also, I think, make it more complicated. Lots more that you can tweak. So that's a path forward that we're working on. We were able to get, 19 classes out of that previous effort that we did. So you can get at least, pretty good vegetation community results from that. And I guess I just want to follow on maybe a little bit on Curtis's thoughts and what Narayan was saying, and also what you folks touched on at LSEP with metrics and indicators and kind of path forward. I just have a few thoughts that I've been thinking about recently. And I think that some of the indicators that float to the surface for me are the channel perimeter, which you folks showed, as a way to an indicator of salmon habitat opportunity, and being able to tie that in with hydrology results to understand inundation frequency at that perimeter edge. So you can kind of develop an index that combines the two things, length plus time. And then I think biomass is another really important indicator, because it really gets to that capacity question. And that's something that can be developed. It's something we worked on with NOAA in the earlier project, where we used some of the data that we had to combine vegetation cover with biomass estimates, and using LiDAR to estimate plant height, combining that into, those predictive relationships for getting at being able to estimate biomass. And I think with the data that's been collected through the ecosystem monitoring program, that relationship can be refined further to get to those estimates. And then, of course, the vegetation classification ties in with that also, so you understand the communities, also invasive species. And then one other metric I think is being used around the country is this unvegetated to vegetated ratio that was developed by Neil Ganju. It's been implemented in lots of different places. Mostly, there's some papers out from the National Estuary Research Reserves, where that's been a useful indicator of change with sea level rise. So I think that's something else that could be broadly implemented across restoration and reference sites to just understand trajectories of potential change, both with restoration and also with climate change. I think that's primarily it. I guess the thought regarding what Catherine just said about, and Narayan, about how this may be implemented, I think is something that's going to take a lot of thought and consideration, but I think having some sort of framework that identifies, some sort of schedule over time that sites are monitored a certain number per year, reference sites and restoration sites, and maybe supplemented with, the other drones that people have to try to get as much information as possible within a reasonable amount of time per year.
Yeah, appreciate that. Thanks. Curtis, you have your hand up?
Yeah, Amy, thanks for that. It was these kind of indicators I think are super important to get together. But back to the machine learning capabilities. So we talked about this when we were working on the other project, but my desire, I guess, would be to see if these are like a model could be made that is versatile and that other people could use as well. So, something that we develop once, or, tweakable perhaps, but that everybody can feed their, for a certain reach, whatever, can feed their data in, so that, we can get this data processed quickly, because this is the big, it took us a long time to get, a really long time to process the data. And I think that for this to work really well, we gotta like get that down to a more a process that's very easily done. So that's the question: can these models be transferable and tweaked so that they actually work for wide regions?
I was kind of thinking, Curtis, of like did I interrupt somebody? I was thinking like a drone processing working group kind of thing, and it may be working on like veg communities, and because I feel like that's what a lot of folks are talking about, possibly, but like using machine learning AI for processing, and just working through that as a community, like Amy, Narayan, Sneha, and Ian and Curtis could participate in something like that if you're all interested, and like how to hone in on that so we're not all doing our separate things and duplicating effort, I guess, basically, but coordinating that. Sneha, sorry, you have your hand up.
No, you're good, Catherine. Yeah, I just wanted to add to what Curtis and Amy had to say. Curtis made a really good point about creating models that was transferable, and in order to get that going, it would be a lot helpful for all of us from different partner organizations to actually try out these models and validate that with the drone data image, like the drone information they're collecting, because clearly everybody also has their own drone capacity at some point, and they're also creating products that are almost similar to ours. So that's definitely like, then I would say that would be like one of the steps that we could take, and that could hopefully lead to like some of the indicators that we could come up with. Yeah.
So maybe like so the idea of like a working group of folks that are interested in and that are working on this, that you all can meet, like, just to kind of work through these modeling scenarios and validation, calibration kind of thing, for starting with veg, I guess, basically communities. Does that sound reasonable? Okay. And I'm gonna, all the folks that I see on the screen, which are Sneha, Curtis, Amy, Narayan. Oh, hey. Curtis just sorry, Curtis. But anyways, does that sound like a good start? Is anybody else interested in that working group? Oh, come on. Okay, all right. Well, we can start with that. And, Elizabeth Martin. Okay. Okay, sounds good. How about anybody else? Does anybody else want to? Oops. Ken Fecho, did you raise your hand to volunteer to be part of the working group or something else? Oh, you're muted.
Oops, sorry about that. It's something else but related. There's just a steep learning curve when it comes to applying the imagery, the data, and there's others in the Columbia Basin that are working on this. PNAMP, the Pacific Northwest Aquatic Monitoring Partnership, they have a remote sensing forum that's currently losing a little bit of steam. And I was just curious if, this working group that you guys are spawning would be available to others outside of the Columbia estuary, because I think that others could benefit, but they may not know about it. And so how do we, is it available for others, like say in the Columbia Basin, to participate in?
I would say offhand, yes, I think so. I mean, at least the techniques I think would be the same in different areas. I think, but the validation, the vegetation communities are going to change within the Lower Columbia, depending on where you are. And then it's also going to probably vastly change depending on if you're outside of the lower river. So, but I think the methods or using machine learning might be relevant for other folks. Am I wrong, Sneha, or anybody want to correct me? Okay.
No, I think you're right. A couple of years ago, Ian and Sarah actually presented some of our techniques at one of their forums. So yeah, it would be a good opportunity to include folks from outside of the region. Basically share their strategies with us and like vice versa. Mm-hmm. So yeah, and I mean, restoration. The goals of restoration are pretty similar. Everybody wants to save like the fish. Everyone wants to make sure like the climate change has been mitigated. So yeah, if we can share our products and share our skill set and share our methodologies across partners, that's definitely like a step in the right direction.
Yeah, thanks, Neha and Catherine. And so if you don't mind, PNAP had a steering committee meeting last week, and they were looking for some contacts to help keep the remote sensing forum sort of engaged. And so I might provide your contact information to Amy Pulse just to maybe figure out how best to do that.
Okay.
Yeah, for sure. Thanks, Ken.
Thank you.
Anybody else on the meeting want to share what you all use drones for, or your interests going forward? Pretty quiet. Okay. If not, we can move into the next conversation, which is the discussion of the process for collaborating on the use of the new drone. And again, I think this is probably going to be a long-term sort of like working out the kinks. So it might entail several of us just kind of sitting down and like working through how this is going to work. But Sneha and Ian, I don't know whether this is where you said you had like some slides to kick this off, or is that okay? I don't want to step on your toes, I guess, basically.
Catherine, quickly, I'd like to share just a quick application that we've been working on while folks are pulling up those slides. Okay. We've been working with the Quinault tribe to do a wetlands classification or a like a wetland delineation determination approach using drones, and sort of been testing out some different classification methods, including some nearest neighbor, like using k-means averaging, and some support vector machine and random forest stuff. So would be interested in sitting in on some of those conversations that the working group is going to be having.
Okay. Sounds good. Thanks, Alex.
Sure thing. Thank you.
Okay. Oh, Tommy, did you have your hand up? Sorry, I didn't catch that.
Yeah, no problem. I was just going to say, here at Metro, you know, with the LiDAR consortium, one of the things I would be interested in is where that sweet spot is between what LiDAR can do really well from a regional, like larger picture, and then where the LiDAR from the drone. First of all, those presentations were incredible and super inspiring. But where that LiDAR from a site level is necessary, like what can we rely on? What are the derivatives that are stable and you can use with the LiDAR? And what derivatives should we be thinking at the LiDAR that we collect in the region? And then where do we also need to go to a further extent? What are the low-hanging fruits kind of things? Does that question make sense, or exploration? I just don't know where the drone is necessary. I mean, clearly you can do some really cool stuff, but I also want to be able to tell the community that the LiDAR that we're collecting is also good for this level of stuff.
Yeah, I think Ian, you can correct me if I'm wrong, Ian, but I feel like you're talking regional LiDAR, which is going to be a different spatial scale than we are collecting at an individual site scale. And I think part of the reason why we are interested in the individual site scale, and this is going to be up to like engineering firms, is whether we can use the LiDAR we collect at a site for engineering designs of a restoration project. So it's got to be a really, really tight, very accurate in order for that to happen. So it might be a different scale. So Ian or anybody else can correct me if I'm wrong there.
Ian, that's yours.
Oh boy.
Go for
Okay.
it.
So a lot of the data we collect is like 2 centimeters, 2 to 5 centimeters vertically accurate. And we really focus on the wetland plane itself. So we're not so much concerned about those hard surfaces. Like we really focus on the micro topography of the site. So there's small little lumps and swales that you find around like a giant wheat canary grass patch, like the thickness of that, I guess, ground surface it's generating, the root mass. Like that's what we look at basically, as opposed to that, you know, the Metro LiDAR, which is like 0.5 meter or whatever. And it's very expensive and very accurate still. Like when we have holes in our LiDAR, we definitely use that and fill it in with that. So, yeah.
So Tommy, does that answer your question? I think they're both very important. They're just different.
Yeah, no, it's super helpful. I mean, I think it's one thing, it's kind of going to that managing expectations. Some people are like, oh, we need LiDAR for this site, which is maybe not a wetland or maybe doesn't need that micro level. And so trying to understand that these are the types of sites where that drone level is really helpful, because those small increments make a huge difference. And then a different type of restoration site or a different type of analysis, this LiDAR is also very helpful and sufficient.
How did you want to respond?
Yeah, I'd just like to add to that and say the level of LiDAR that you would need would also depend on the question that you're asking, what your restoration goals are, and whether whether that scale of LiDAR wouldn't be needed to answer your question. Like for us, most of our restoration sites have goals of channel development, of providing salmon habitat opportunities, identifying cold spots. So for these kinds of products, we definitely need our LiDAR. But if you're thinking of a project where it's just presence absence, if you're thinking about the larger bathymetry scale, then yes, you would have to either downgrade your the amount of data you're collecting or significantly scale it up, because if you're thinking of bathymetry, you would be thinking of green light or, so I hope that helps.
Amy, do you have a response?
Yeah, I was just gonna say that I think that larger scale regional LiDAR is also super important for other kinds of regional assessments, and also for scaling up the information that is gleaned from the site scale with a drone to be able to more broadly apply it to areas that aren't covered with the drone. So other reference areas, other restoration sites, whatever that might be.
Yeah. Okay. Great. Thanks, everybody. Any other discussion points or questions before we move on to this? And again, this is probably going to entail some kind of working group, or at least a group of us sitting down to kind of talk about metrics and questions that were, as Sneha said, like, what questions are we trying to answer with using these drones? So yeah, so let's kind of get into that conversation next, which is, we talked about capabilities of the different partners and folks using drones. And so I think the question is, how do we work together to best utilize all of our different capabilities, I guess, and collaborate? So, and I think some of that is like for each site, one of the things that we've been talking about internally is that working with partners like Narayan or Crest, specifically the restoration folks, to identify those issues or questions they have when they are designing a project, and identifying what their hypotheses are, what their metrics or performance criteria or metrics of like how this project is going to function, and coming up with performance metrics. And then that would allow us to develop a site sampling plan and come up with a collaborative way of implementing that site sampling plan in a partnership, I guess, basically. So not sure how to go about having this conversation, I guess, but yeah, so I think the thought is like, how do we start thinking about doing this as a group? Any ideas from folks? Like, I'm going to pick on Narayan and Amy a little bit because you're already using drones, and maybe Curtis, is to like how it makes sense for us. We can have this working group that works through vegetation, machine learning on vegetation communities, but then are those, like, can we start thinking about like, what are the metrics that we're collecting, and does that make sense for action effectiveness? And then I think getting into Curtis's discussion about, we also want to compare our restoration sites to reference sites, so we also need to be collecting the same sort of metrics at nearby reference sites. So I think that gets into that conversation about what are our questions, what are we going to measure, what are our indicators, so that we can develop that indicator or that predictive model for determining where we are with our individual restoration sites on that trajectory of recovery. So does anybody want to like have a conversation, or like want to pop in with some recommendations on how they see what would be beneficial for you in working with this drone equipment, and how would you want us to work with you, I guess, basically, going forward? What would be the most convenient and useful for you all?
It seems like collaboration on multi-spectral imagery. Oh, sorry, Narayan, do you want to go ahead?
Go ahead. Go ahead, Alex. You can go ahead.
Oh, excuse me, sorry for jumping in there. It seems like a lot of the partners either have or soon will have multi-spectral imagery capabilities. So that might be a good place to start in terms of democratizing the overlap and seeing sort of how folks can work together on that. And then maybe how LiDAR could supplement those efforts in terms of doing like relative elevations and differencing for like surface models versus terrain models to pair with some of that vegetation work that could be done with the multispectral imagery.
All right.
Yeah, can you hear me?
Yeah.
Okay. Yeah, I agree, Alex. Multispectral for sure. And then also we don't need to double up on things. Anything that's part of the AIMER 2 or anything that LSEP is going to be using the big drone for, we don't need to double up on that. So we would fill in those gaps at our particular sponsor sites. You know, CLT will fly theirs, we'll fly ours. And then the working group will act as as a planning and calibration of the models or products we come up with. Yeah, I think that's a good place to start. Multispectral, you guys fly AIMER 2 and we fly all our other sites that we're going to fly anyways.
Yeah. Well, I appreciate that. So one of the things I think in trying to change up the action effectiveness a little bit is that historically we the monitoring team sort of does this a little bit. I guess basically trying to figure out like, okay, so if we have this list of level 2 sites, we have a list of level 3 sites, and maybe we change those up, because if folks are collecting their own level 2 stuff, then maybe we don't really have a level 2 versus level 3. But anyways, maybe we come up with a prioritization of sites. But I do think like Sneha and Ian and Derek sitting down with the Jason Smiths or the Ian Sinks and coming up with like, okay, these are the questions you have for that restoration design. And then working on a site sampling plan as to like, how are we gonna test these questions? How are we gonna know whether this project is successful or not? And that's what we use. We come up with a partnership, sort of like, not Estuary Partnership, but like a collaborative like site sampling plan that comes up with a list of questions where we're going to put the ground control points, what the deliverables we want, and what accuracy. Do you just need multispectral cameras, or would you also like to have thermal imagery? Would you like to have LiDAR sort of thing? So working through all these different products that we could produce. And so anyways, yeah, I think that would, and like who's the roles, I guess, of each entity. Like we don't want to be out there by ourselves. We want folks to be out there that are designing this project so they can make sure we're doing it correctly and that they're getting the products they want out of it. So does that make a little bit more sense? Alex, you got your hand up.
Yeah, I think that totally makes sense. I just wanted to, it seems like there's a lot of folks on the call that aren't maybe familiar with the different levels of monitoring. So could you fill folks in on what like level 2 and level 3 monitoring is in the estuary?
Yeah, sorry, folks. This is, it's very much for the Lower Columbia and BPA and Army Corps funded projects. And all projects that are funded get at least some basic sampling, monitoring pre and post construction. So that would entail, that's the level 3, which entails sediment accretion, photo points, water surface elevation, and water temp. And that's pre and post. And then like level 2 is a little bit more hands-on. We get vegetation community, channel cross sections, in macroinvertebrate flux kind of thing. So, but it seems like folks are kind of wanting to meld the two all together. And it sounds like folks want to do their own level 2 at their site. So then the question is, is our role with the drone in our role with our capabilities going forward? And how do we leverage each other's capabilities, I guess, basically. So Curtis, I think you have your hand up as well.
Yeah, so the choice of instrument is kind of crucial to sort of get on board now, especially if we're going to be working for AI models or machine learning, because it's wavelength dependent on how the categorizations work, right? So I think we should, I mean, the multispectral cameras seem to be the way to go. More bands than RGB. Obviously, we want the near infrared, was super informative. I do love the hyperspectral stuff, but it's overwhelming, So, as we go forward and we're thinking about like, how are we going to make these models and getting the processing done, we should pick a basic, instrument that we can use, which seems to be one of the multispectral units. Because only then can we, and everybody should, survey with that kind of unit as a base thing. The other stuff that we can add on is gravy, and it's excellent, but we need to have some kind of like baseline standard for the measurements. So let's keep that in mind as we think about instruments and the processing capabilities.
Great, thanks, Curtis. Amy?
Yeah, let's see. I agree with what Curtis just said. I guess I'm just thinking about the working group and sort of a path forward of what this might look like in this kind of collaborative method. I think that the working group maybe is a little bit broader than what we've been mentioning, which is focusing at least first on these vegetation classification methods, which I agree with what Curtis just said, that if we can focus it on using 5 bands, which will be able to be applied with all the different partners that have those kind of drones, and using that kind of methodology, that would make it useful at a larger number of sites and kind of tie into the framework of monitoring and how drones are being used. So if I think that's the other thing that the working group should maybe be focused on, is developing the list of indicators and who can do what. So, if we have these drones that all have multispectral, maybe there's at least 3 or 4 of them around the estuary that can be used for the vegetation classification. But then some of the other higher level indicators could be things like metrics developed from the LiDAR, using the larger drone with the LiDAR sensor, and also temperature, which I think has really huge applications for looking at wetland temperatures. That has been very hard to measure to date, at least at that site, landscape scale. I think that's a really going to be a really useful indicator. So I think, I guess I'm just trying to say that I think a working group is a really great idea, and I think it can be kind of useful to implement, kind of this framework. And that means that I think maybe a few more people need to be at the table, including, other researchers in the estuary and other restoration practitioners. So maybe WDFW and PNNL, just to make sure that, we're all working together to develop this plan and really try to figure out who can do what, and some kind of schedule that makes sense to be able to implement this in a reasonable way.
Great, thanks. Appreciate that. Curtis, did you still have your hand up, or did you take it down? Okay. There is a question in the chat. I don't know if anybody wants to take a stab at this, but it's I'd love to hear more about how folks frame cost of advanced drones and analysis. What does it bring to a restoration project that justifies the cost, and how to balance with concerns around disturbance of wildlife. I can just say it's pretty expensive. It's pretty expensive, some of these drones. And I think the big drones no longer disturb, right? They, sorry, Sneha, you want to go for it?
I can take it, Catherine. So we usually, so if we're talking cost-wise, we usually calculate how much, what it's going to cost based on like acres per flight. However, so again, I'm going to go back to like what your questions are and whether your products are going to help you answer. And that's when we need to sit down, develop those questions, understand what the products, like what products you would need, and then we would go out and collect all of this data, and how this products help you will affect project planning when you're considering after construction, when you're doing monitoring and everything. All of these products also kind of help you adaptively manage when your construction is almost done and the site is brand new. It helps you track the evolution of the site back to minimally disturbed conditions. And also, if there is something that we see that's not going according to plan, that's where your adaptive management thing also kicks in. Concerns around disturbance to wildlife. I mean, the big drone, it's pretty big. So we have had instances where the birds have gone away from it, but it's not, I mean, to be fair, it's not any more disturbing the wildlife than your normal DJI drones would. So I hope that answers your question. And if anyone else wants to supplement my answer, please go for it.
I think Jim Brooks, I don't know if you can answer this, Jim, but ODFW considered potential impacts from the use of drone birds and other wildlife species and implemented recommended best practices to avoid impacts, and then cites a couple of references. There you go.
As part of our grant for monitoring, effectiveness monitoring on restoration projects in the Clackamas Basin, we had to search best management practices to avoid these. I actually have not read these references, and I'm not our agency person who's doing the drone, but I just wanted to put those references in there for folks. They could look at those and see what we have incorporated into our efforts in monitoring the Clackamas restoration projects.
Great, thanks, Jim. Appreciate that. Time check. We have about 5 more minutes, and I know Sneh has to take off. So it does sound like I hear interest in having at least one working group and potentially a broader one that's specifically looking at like machine learning for veg communities and the metrics that way. But then I think there's another, it could be a broader community that gets together and decides on or recommends indicators or a list of indicators and what we're going to collect going forward with both restoration sites and reference sites, and what we can use the drones for and the capabilities of the different partners for those different efforts. So did I capture that correctly? Does anybody want to correct me or add anything to that? Alrighty. Okay, well, we got a couple more minutes. Is there any other questions? Any last minute emerging issues or anything that somebody wants to talk about relevant to drones or remote sensing? I'm going to just say one last thing is that this is remote sensing. We did capture as a lot of you are familiar, we do have land cover data set from 2009. A lot of you helped with that. We are hoping to repeat that land cover data set. That would be for the entire lower Columbia. in the same sort of study area that we did before. So we're hoping that we have bipartisan infrastructure law funding. So we're hoping to repeat that using NOAA as our contractor. So hoping to have that done in the next year or so. Just FYI, that's a larger scale data set, but just FYI that hopefully will come out within the next year, and we'll probably be pinging a lot of you to help us with the calibration, because again, that's going to probably use remote sensing and machine learning to try to identify the changes from the last land cover data set, basically. But we'll need help in like going to the sites to validate that data set. So, if nothing else, I think have a lot of lists of topics for future science work groups. Potentially one of the next science work group would be convening a group about indicators and like what we're all going to work on going forward with action effectiveness and reference sites. That might be a topic for a future science work group. So involving the broader community. Alrighty. Nothing else. I'd like to thank all of our presenters. Sneha, Ian, Curtis, Amy, Narayan, thank you so much for everything. They're really outstanding presentations. So,
yeah, no, I was just going to say thank you for listening and bearing with all of our, explanations of all things. And we're looking forward to sharing our data products with all you all. So, yeah.
Thanks, everyone. Have a great day.
Thanks, you too.
Thanks.
Bye, everyone. Thank you.
Yeah.